Hey guys, it is time to unbox a new toy. I hope this will be, well, basically the final piece in something I teased a while back that I never got around to talking about or finishing off for a variety of reasons, which I will discuss in a moment. Well, what I'm getting at is I want to set up a home transmitting setup, both for TV and radio. Radio is pretty easy because I was lucky enough to get an SS Tran before they closed business, and I've already assembled it and it's working. I just haven't set it up at the new home yet. The other is a TV setup, and I've talked about this in the past. I've played around with a variety of TV transmitters, modulators, but I want to take it up a few steps. So in the past, I just took one of those over-the-air converters and just fed it into a blonder tongue modulator that has enough output power to transmit, I will say, 50 feet, 100 feet, and that's as far as I went. Well, now, if you've been watching some of my unboxing videos from a while ago, you saw I got some waveform monitors, basically broadcast quality equipment that lets you observe the signal that, in this case, I would be transmitting. Well, this is another piece of that puzzle. So I now have monitors, I have modulators, a variety of signal sources, DVD player, over-the-air converter box, whatnot. But what this should be, is a test pattern generator. But unlike the Sencor VG91 I've used in many, many videos, this is not meant to be used on the benchtop. This is meant to go into a rack, and I believe either to calibrate the equipment at a TV station, say, or to broadcast a test pattern. Back in the day, you had the Indian head test pattern, but later on, they would show color bars on some channels at night, and I think they may have used a device like this to generate them. They can do a lot of other patterns besides that. The main reason I haven't done anything with it is well, you're about to see why in a moment. The underlying issue to me setting all this stuff up is it's all rack mount. And this one especially, I didn't realize it was this deep. I picked up a rack last winter and I thought, hey, this would be great to use this stuff in. It's not good enough. Some of the gear doesn't quite fit in there right. Some of it's too deep, like this will definitely be too deep. But also the way the sides are cut internally, some stuff doesn't quite fit into them. The ears fit on the front, but the sides don't quite fit in. Anyways, looks like this had a spring lock mechanism on it. So what I need to do is order up myself a modern rack. And there's a plethora of them out there. I got kind of lost looking through all the offerings online because, of course, they use them for servers these days. But this is throwing me off a little bit because I thought I would need to get a rack about that deep, but not quite this deep. So I either need to get a box that's that deep or has an open back so they can just stick out the back. Anyways, so it's very slim, but yeah, it's kind of big overall. So this is Tektronix. Tektronix made just like those waveform monitors I picked up. They made some other broadcast equipment. So this is a TSG-170A NTSC television generator. So we can do all these test patterns. And for a lot of these test patterns, there are options behind them. So the usual crosshatch, color bars, step, burst, with a plethora of subtle tweaks you can do to them. All controllable by this touch panel up here. So it looks like each pattern picture is actually a button. Now I'm curious. So there's a light above each symbol, and each symbol is a button, but below each symbol there are other functions. So I don't know if there are modes you need to get into to do various things, or do the pictures have nothing to do with what these buttons do, and what these buttons do is what's indicated below, and the light above indicates which pattern you're using. I suspect that's the case. Let's see. So test signal. Alright, now on the back, a ton of connectors. Okay, power, that's good. It's a standard power connector. We can deal with that. Power, simple enough. I can do 115 or 230. It's in the 115 position. Looks like it has a cooling fan, I think. And then a whole bunch of BNC jacks. I believe the one we would care about now to play around with it is the test signal out. So I think what I would do if I wanted to set this up to broadcast it, was this output would go to the input of my RF modulator. So here's what I'm envisioning, because I'm getting real tired every time I work on a set. I'm getting tired of having to play musical chairs with test equipment. It's a little awkward to keep various modulators, test pattern generators up on the workbench at all times, depending on what kind of TV chassis I'm working on. So I generally keep that stored below the workbench, and I pull stuff out as needed. Or I feed in an over-the-air converter box to see some broadcast material. It would be so much more convenient if I had an over-the-air source, or sources. Then I could just hook up rabbit ears, and I don't care if it's perfect. I just, when I'm kind of in the early stages, like with this set, when I first powered it up, I wanted to see, can I receive something? Can I get some sound? It'd be cool if I had an over-the-air source. Doesn't have to be a perfect picture, really strong, really clear, just something, so I get some indication that the set's working, the tuner's working. So what I'd like to do is on one channel broadcast these test patterns. On another channel, whatever, live programming, MeTV, whatever. So basically use two RF modulators, maybe channel 3 and channel 5, something like that, and just have them running all the time. Got to keep it low power to keep it legal. But I mean, heck, I could set it up so that they're 5 feet away from my workbench, so I don't really need a whole lot of power, I don't think. Now, by no means does this eliminate the need for a device like the VG91, because it can do other things, like you can do signal injection, you can generate markers for alignments, and such. Wow. Okay, so there's definitely a whole lot of digital stuff. Man, it's like a whole friggin' microcomputer in here. There's some serious looking analog stuff going on, and then there's a very nice looking power supply, and yes, a little cooling fan. Wow. Hey, it's got a Zilog in it. Let's unmount the camera on deeper dive. That's very impressive looking. Boy, there's a lot more going on than I expected, but it looks very, very familiar to me because it's from the late 80s, which is my sweet spot for when I learned electronics. I would go to Hamfest and buy circuit boards look like this all the time. All these chips are so familiar to me. All this 74 series stuff. So we got LS for low power Schottky. We've got AS for high speed Schottky. Got Cypress, it's either a PAL or memory, 35 nanosecond. Bunch of EEPROMs, socketed. AMD EEPROMs. And Zilog, Z80 based. So we got a CPU and a couple CTCs, counter timer chips. 74F for fast. We've even got some ECL in here, so man, they really and an ALS, just to just for fun. So we have what, at least 4 families of the 7400 variations, I should say. So different technology. So these are all, most of these chips are gates or registers or buffers. So the 74 indicates just the whole family. The last digits indicate what function the chip is, but the letters in between indicate the chip technology used. So as I mentioned, LS is low power Schottky, AS, I forget, I know it's high speed, I don't remember what the letters stand for. F is, well, fast. ALS is advanced low power Schottky. Originally they were all TTL, but then they started branching out to improve the characteristics. It's kind of weird to put LS and AS and ECL all side by side, though. ECL, emitter coupled logic, really high speed stuff. This would be 10K series. That's these Motorola chips. Much faster gate switching times than TTL. Alright, so we have this big old box here. I think that is the time base. And there's a hole above it for internal subcarrier frequencies. So that might be an oven. So this was quality stuff here. So they wanted to have a very, very accurate time base to generate all the timing signals to meet the official NTSC specifications. And then there is the aptly named analog board. Man, I'm not sure what all this is. I'm sure they'll want to have some amplifiers. This is supposed to drive 75 ohm cable, but it doesn't put out a whole lot of power. This does not broadcast power by any means. So why is it so complicated? Unless they have separate amps driving different outputs, which is certainly a possibility. Some of these might be inputs as well. Like I think you can lock this, say you had several of these, you could lock them together so that they were all putting out the pulses, sync pulses at the same time. Some logic chips mixed in here. Looks like some custom Tektronix chips. But these are going to be your amplifiers here. Imagine those are carefully selected transistors and whatnot. I think those brown things are, the resistors or inductors, I'm guessing. I'm not entirely sure. Wow. And then the power supply, which looks to be very well designed and in really good shape. But overall, do you see any dust bunnies? Do you see a speck of dust on that fan? Was this thing ever used even? It doesn't look like it to me. These connectors are all super clean too. I've seen stuff taken out of labs that's just beat the heck, where the connectors are chewed up from hundreds of things being connected and removed, and the inside would be coated in dust and the fan would be clogged. I mean, this is crazy. So we have a big blank spot here. There were options. There was a hole above that area on the top that says audio level option 1 only. I imagine that could set the level of the audio carrier. So this might not even have audio capabilities. I mean, it might not put out a test tone at all. It might just be video, which would be kind of a shame, but so be it. I imagine I could rig up an audio oscillator just for that, assuming this has an audio in. Or sorry. I mean, if I'm going to feed this into a modulator, I can use just this for the video and use something else for the audio. Bulging caps. What brand are these? I'm not sure. They were Nichicons at first, but I don't see. Oh, I can't think of the name, but I believe I know the brand, and they're high quality, Japanese. The name escapes me at the moment. Sorry. All right. Yeah, I'm thoroughly impressed. Let's try powering it up. Now that leads us to the question of how do we know it's working? If I turn this on, maybe we get some indicator lights, the fan runs. That's it. Well, that's where something like the companion Tektronix waveform monitor comes in very handy, because you can hook the output of this to the input of that, and you can actually see it. I will dig one out later, but for now, we'll just hook it up to a scope. I have that going to the test output. Let's get the scope going. And give this a try. Let's see. Power input is back. This thing is so deep, I only got to reach to get to the power. A bit louder than I would have expected. We have a red LED on. We have a green LED in the front. We have a couple. One, it's lit up now to a select test signal. Okay. Alright, so scope. That certainly looks like something. I was wondering why I just hooked this up to a TV, because all the TVs I have only take RF modulated inputs. I don't have any that just takes a signal like this directly in. So I'll try a different test pattern. Oh yeah, that's doing stuff. Once I get to use the TV capabilities of this scope, so there is a single line, that's the color burst, and there's the test pattern. Oh, let's try something else. Let's try this guy. The only thing is, when you're in single mode, I don't know how you re-trigger it. That must be the multi-burst. So the multi-burst is interesting. It's a good way to test bandwidth. It does bars. It does, in this case, 6 sets of bars, and the bars get progressively closer together, or stripes I should say. So here we get maybe 3 stripes, 4 stripes, 5, 6, 7, 8, something like that, maybe thinner and thinner. So by the time you get to the right side of the screen, if you can still distinguish the vertical lines, you've got really good bandwidth. But anyways, that's what the pattern looks like when you see one individual scan line. So this portion in here, that is the video, and it's amplitude modulated. So if you're all the way up here, it's white. If you're all the way down here, it's black. And that is a horizontal sync pulse, and that is a color burst. Oh, and on the farthest one here would just be a single bright bar. Staircase pattern. Yep. So this would be your gray bars. So starting out of black and then going lighter and lighter shades of gray to get to white. I dug out my Tektronix waveform monitors. I have a Tektronix 1740A and 1750A. I did dedicated videos on these a while back. Briefly, these are a combination oscilloscope, vector monitor, and TV monitor. The oscilloscope would be sort of if the settings were kind of hard-coded just for video signals. So for example, if I go to the waveform here, that is like we were seeing on the oscilloscope earlier. But if I go to picture, that's actually the image that you would see on the TV. There's a crosshatch pattern. It's a square with a couple lines to the side. There's the multi-burst pattern I was talking about. These waveform monitors, I think, are a little worn out. It's not quite as crisp a display as I would expect for something like this. Regardless, let's keep going. What else do we have? That's the multi-burst. That's color bars, I think. I'm not sure what these are. Too hard to tell. This is the mode I was wondering about. I knew something was changing, but I couldn't tell what. This is the bounce. I guess it bounces between two different test patterns. Ooh, almost forgot about the other symbols button. I expect some of these have some color going that we just can't see on this waveform monitor. I was really hoping one of these patterns would have a circle. I haven't seen that yet. I think that's it. I think we've gone through all the patterns. So with all that circuitry, they couldn't do a circle, huh? Oh well. You can do linearity well enough with a grid, but a circle's kind of a nice thing to have too. Here's a very crude demonstration of what I'm trying to eventually achieve. So the test pattern generator down there, feeding up into the modulator, which is a very short power cable, so I had to put up on the workbench. Output of the modulator is going to a very hastily constructed dipole like that, the length of which is not optimized for this frequency. And then here's a TV I'm working on with, again, a very crude antenna, but it is receiving the signal. Not very well, but get myself in the mix and grab a hole, I can improve the reception a little bit maybe, or not. But that's the idea. I do have this modulator cranked to maximum output, but I'm not 100% certain it's working properly. It does not have as much power as the larger agile modulators. So right now I'm broadcasting all of about 2 feet, which is not great. But I hope we can improve on that for sure. But even so, this is what I'm talking about, being able to just throw up a crude antenna, turn the set on, and get a signal. So if I can get all this equipment put in a little rack, like say a wedding singer would have or something, or a portable, band setup, so a rack unit that's got maybe 8 units high or something like that, and get the monitors, test pattern generator, a couple modulators, and so on. Well, I think that'll be it for now. I need to study up more on what all the controls can do on this device. I just want to give you guys some idea of where I was heading with all this. The main problem I've had with transmitting is getting a clean signal at any distance. I've heard others have had great luck with these. I haven't so much, but we'll be experimenting for sure in the future. Thanks for watching.